All right, guys, so this is the first day of Unit 4, which is all about measurements and calculations. As we move forward and do some more math with our chemistry, we need to make sure that we can take proper measurements and do proper calculations. So today is all about proper measurements. These are the type of measurements that we will be taking in this class. So mass, the amount of matter within an object; distance, the length between 2 points; volume, the amount of space an object occupies; temperature, the amount of kinetic energy particles within an object have. So basically, the amount of movement energy that particles have. The faster they move, the higher the temperature. And we will also do time, the duration between two events. You should be comfortable with these different systems of measurement and their definitions and some of the common units used to measure them. You may have noticed that all of the measurements were from the metric system. That is because in science we use the metric system exclusively. So that's meters, grams, liters, etc. So we will not use pounds, inches, anything like that at any point in here. Basically because the imperial system, the one we use in the United States, is stupid. Only 3 countries in the entire world use it, including us. And every other country in the world uses the metric system, and therefore the scientific community uses the metric system. It makes more sense. It's based on powers of 10. It's easier to use. So we will never use inches in this class. So if you ever want to come up to me and say, Ms. Miller, should I measure this in inches or centimeters? The answer is always going to be centimeters. One of the reasons the metric system is so much easier to use than the imperial is because of the prefixes that are used. So for example, these are your 3 base measurements: meters, liters, and grams. And then these are the different prefixes that can go in front. So millimeter, milliliter, milligram, centimeter, centiliter, centigram, etc. And all of these are based on powers of 10. We will use this number line a little bit more later on, but this is kind of the basis of the metric system. So your big goal today is to walk out of here being able to take a measurement. While it seems like a fairly simple task, there are some key elements to it to make sure that you're doing it properly. The first thing that you need to do is determine the smallest increment on the measuring tool. So for example, we're going to be measuring the length of this pencil using this ruler, and this ruler is measuring in centimeters. So we want to figure out what it's going up by. That's what it means by smallest increment. So if we're thinking about a traditional number line, with this being the ones place and this being the tenths place, you want to figure out what this is counting up by. So I see a 7 and an 8, and then I see little lines in between. So this would be 7.1, 7.2, 7.3, which means this is going up by the tenths place. So that's what the smallest line on the tool is measuring. So that's always step 1. Your next step after you figure out what the smallest increment on your measuring tool is, or again, what it's counting up by, so what these little lines are representing, your second step in the process is to determine the next decimal place after. So if this is counting by tenths, the next decimal place after will be the hundredths. And this is how far back your measurement should go. This spot right here is going to be called your estimated digit or your uncertain digit. Every proper measurement has an estimated digit or a guessed digit within it. And it's always going to be 1 decimal point beyond what the smallest increment is. So putting all of our steps together, this is what the proper measurement of this pencil will be. So remember, it's counting by tenths, and 1 estimated digit past is the hundredths. So when I'm looking at this pencil, it goes to about right there-ish. So I would say this pencil is 8 8 it's kind of in between the 2 and the 3 there, so I'd say 8.2. And these are my certain digits, the ones I know for sure. But I'm always going to have a guess digit. So I'm going to go 1 point beyond and say 8.2. I'm going to guess 1. And then put my unit centimeters. This would be a proper measurement of the pencil. Now, this last digit here, this is a guessed digit. This is an estimated digit. So some of you might have been thinking 8.22. That's completely valid. Some of you might have been thinking 8.20 or 8.23. Anything like that is fine. We can vary on our guessed digit. But if you're taking a proper measurement, we would all say 8, we would all say 2, and then we've got our guessed digit over here, which we put as the 1. So really, the only key with taking a good measurement is take the measurement and then go 1 digit beyond, and that is your guessed digit. One other thing to note is whenever we're measuring a liquid, particularly in graduated cylinders, sometimes the water dips like this, and we call that the meniscus. It's kind of a fun word. And we always want to measure at the bottom of the meniscus. So we would measure here rather than up here whenever the water's doing this. So let's go ahead and let's try this out. So what I want you to do is I want you to pause the video. I want you to take the measurement of the water in the graduated cylinder here and figure out if you think it's number 1, 2, 3, or 4. So I want you to try it, pause, and then play the video to see what the right answer is. The correct answer is number 352.8. Here's why. So if we're going through our steps, the first thing is to figure out what the smallest increment is, what it's counting up by. So I see a 50 and a 60. The little lines in between, this must be 51, 52, 53, 54, 55, etc. So I am counting by ones when I'm counting up the smallest increment. That means my estimated digit will be in the tenths place. So when I go to actually take the measurement, it's in between 50 and 60, so I'm going to say 50. It's in between 2 and 3, so I'm going to say 52. Those are my certain digits, the ones I know for sure. But then I need my guess digit, so I'd say 52.8 milliliters. And again, this is my estimated digit. This is my guessed one. These are the ones I know for sure. All right, so let's try this again. So go ahead, pause the video, decide which measurement you think is correct, either 1, 2, or 3, or 4, and then push play when you're ready. The correct answer is 8.0. So again, going through our steps, you want to figure out what the smallest increment is. So what is it counting up by? So we've got 0 to 10. So if I'm going from 0 to 10, it looks like I'm counting by 1, 2, 3, 4, the ones. So I'm counting up by ones, which means my estimated digit will be in the tenths. So when I take my measurement, it's at 8. And I think it's right on the money. I think it's right on the line. So I'm going to say 8.0 rather than 8.1 or something like that. I think it's right there. And then millimeters for my unit. This one's not right because it doesn't have the estimated digit. So it just has an 8 rather than 8.0. This one has too many digits. This one would have to be counting up by tenths in order to estimate to the hundredths. And this one was kind of just off the board here. All right, go ahead and try it again. So I want you to pause the video, try to figure out the measurement, and then push play when you're ready. The correct answer is number 3. So again, going through a process. So we have 200, 60. We are in between the 5 and the 6 here, so that'll be 265. And then again, what is it counting up by? So these little lines are counting, I see a 5 and a 6, so 5.1, 5.2, 5.3. So I'm counting by tenths, so I estimate to the hundredths. So 265.7, because it's right on the 7, it's a little bit after, I guess a 2. So again, you always need to have this guess digit sitting at the end that is 1 decimal point beyond what it's counting up by. This is just a quick review from something you've probably covered in math class, just being able to write numbers in scientific notation. So for example, if you've got these really big numbers, you take the decimal point and you move it in between the first two non-zeros. And then you count how many times you move it. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'd write this as 6.94 times 10 to the 9th because I moved the decimal point 9 times. For small numbers, you move the decimal point the other way, still in between the first two non-zeros. So this one would be 1, 2, 3, 4, 5. So I would write 4.36 times 10 to the negative 5 if it's a small number. And for this last one, same thing. 1, 2, 3, 4, 5, 6, 7. 1.206 times 10 to the negative because it's small number. 2 vocab words that you should feel comfortable as we're learning how to take measurements is accuracy and precision. So accuracy is how close to the true value a measurement is, where precision is how repeatable the measurement is. So for example, if I wanted to be accurate, I would aim for the bullseye of a dartboard. I could be precise by constantly hitting the same spot over and over and over again. I could be both accurate and precise by hitting the bullseye, which is accurate, and precisely hitting it multiple times. In terms of measurements, here's how this works. So I have 2 beakers here that have the same amount of water, and I have the measurements up above. So just to review really quick, this first beaker on this side, notice how it's counting up by ones, 1, 2, 3. So when I'm looking at my number line here, it's counting up by ones, so I should go to the tenths. Hence why I said 1.2 with the 2 being my estimated digit. Now over here, same amount of water, but now this one's counting up by tenths. So I've got the 1, 2, and 3 with the little lines in between, so this is going by tenths, so I estimate to the hundredths. That's why this one goes 1.23 with my estimated digit. Now, the first question is, which one is more precise? Remember, precision is how repeatable a measurement is. This beaker is more precise because it has more repeatable digits. Notice how if everybody in this room were to measure this beaker, we would all say 1 and 2. That's 2 repeatable digits and only 1 guess digit, only 1 digit we would vary on. Over here, this beaker only has 1 digit we'd all agree on, and then we'd have another digit that we all could be guessing on. Like somebody could totally say 1.3, 1.1, and that would be completely valid. But then we're only agreeing on 1 number. Over here, we would agree on 1 and 2. 3 is the one that we would vary on. So this one is more precise. But, and this is the trickiest thing, both beakers are accurate. Why? Well, they're both getting you close to the true value. We're talking about 1.2 versus 1.23. That's pretty darn close to the same thing, right, as far as value goes. One's just doing it more precisely. And pretty much every measurement you take should be accurate. Unless your ruler or your graduated cylinder was made completely wrong, every measurement you take should be accurate. It should be close to the right answer. It's just a question on whether or not it is more or less precise. So the more digits that are in the measurement, the more repeatable the measurement, therefore the more precise.